Hi. Welcome to analysis of prestressed concrete slab, using ETABS and RESPONSE-2000. In the past, prestressed concrete slab design can be done using the equivalent frame method. This is to simplify the actual floor slab into several equivalent frames. Current technology allows structural engineers to design prestressed concrete slabs using 3D finite element modeling. This enables the structural engineer to consider the structural behavior of the whole floor at once. The shell element of the floor, the restrained effect from columns and walls, and all the tendons can be modeled, which helping structural engineers to understand the structural behavior much better than the equivalent frame method. In general, there are two methods for modeling prestressing effects. The first method is that the tendon is not explicitly modeled. The prestressing forces are converted to an equivalent load acting directly on the structure. Since the tendon is not explicitly modeled, there is no actual interaction between tendon and structure, therefore there is no direct elastic shortening loss. The elastic shortening loss needs to be considered indirectly and separately. The second method is that tendon is explicitly modeled. There is a direct interaction between tendon and structure and the loss from elastic shortening can be observed. This method also allows the interaction of tendon stress and structure at various load combination and provide more reasonable structural behavior than the first method. Now let's study the simple prestressed concrete slab. The slab dimension is 10 meters in width and 10 meters long. The boundary condition is simply supported. The service load and material properties are as shown here. The tendon profile is a parabola. Each tendon contains 4 strands. There are 9 tendons in total with the jacking stress of 1,488 megapascals. By using RESPONSE-2000 and input these data, we get the stress of concrete at the top surface, middle, and bottom surface of the concrete slab. And also by using ETABS and input these data, again, we will extract the stress of concrete at the top surface, middle, and bottom surface of the concrete slab. One thing that is worth mentioning is the applied force of 5,303 kilonewtons is almost identical to the ETABS strip force of 5,351 kilonewtons. This means there is no elastic shortening loss in ETABS model. And therefore, the tendon is not explicitly modeled. The summary of stress due to jacking force by manual calculation, RESPONSE-2000 and ETABS is as shown here. And repeat the same workflow for load combination of jacking force and service load. The summary of stress due to the combination of jacking force and service load by manual calculation, RESPONSE-2000, and ETABS is as shown here. This page summarizes all the results. Understanding this kind of simple prestressed concrete slab is the first step in preparing yourself to get ready for the prestressed concrete slab design.